Hello everybody. In this video we're going to talk about the last part of this chapter, which is the calculations related to chemical reactions. And this is kind of thing that we need a lot, and we face a lot in our chemical engineering applications. So let's take an example of this reaction of two of A reacting with me, giving C and T and D. From this reaction we will learn many things. The first thing is that A reacts with B, so these are the reactants, and C and D are the products. And we will learn that each molecule of B reacts with two molecules of A to produce three molecules of C and four molecules of D. And this is pretty important because this balance of the equation, these numbers tell me exactly the ratios between the reactants and the products. And I have to make sure that the equation is balanced so that the number of atoms of each species in the feed or in the left hand side equals to the number of atoms of this species in the right hand side. So this is one thing which is pretty important. So from this balance we can tell that this is the ratio that 2 moles of this reacts with 1 mole of B to produce 3 moles of C and 4 moles of D. And this is very useful because if I know one information about one of these four molecules or four species, I can get the information about the rest of them. For instance, if I know that the number of moles of A that's going into the reaction is 5, then this means that this 5 needs to react with 1 over 2 of this 5 uh, of B, the half the amount of B, and 1.5 times of C, and to produce 1.5 times of C and 2 times of D. And I got this from the ratios. This is 5, it's like a cross multiplication. This equals this multiplied by this divided by this. 5 by multiplied by 1 divided by 2. 5 multiplied by 3 divided by 2, 5 multiplied by 4 divided by 2. These are the numbers that I got. And it's important to keep in mind that this is ratios in moles, it's not ratios in masses. So if I know the mass of one of them, I cannot use it directly to get the mass of the rest of the components. However, I can use the mass to get the ratios if I know the molecular weights. So I can say that this is 5 molecular weights of A and this is 2.5 molecular weights of B. So I'm getting the mass ratios from the mole ratios. I'm multiplying each one by its molecular weight, and then I'm getting the ratios, or getting the masses of these components. But I cannot directly say that this is or this is double this. It's a function of the molecular weight as well. So it's not just the ratios, it's the ratios and the molecular weights. To understand this well, we can check this example. In this example, we have the reaction of calcium chloride with silver nitrate, producing calcium nitrate and silver chloride. And in this example, we need to know the mass of calcium chloride, which is this, that I need to put into the solution to produce or precipitate 200 grams of silver chloride. And I know that the atomic weights of calcium, chlorine, and silver are 20, 35.5, and 107.8. And this is what I need to do. So again, in a case like this, I need to make sure that, or I know that I'm gonna get, or the only relation between silver chloride and calcium chloride is this chemical reaction. And this chemical reaction is ratios between moles, not masses. And I know that I have already, before even I go into the calculations, that I have masses, and I need to go or get the ratios by the moles. So I need to use the molecular weight in a way or another. So I first calculated the molecular weights of the two species of interest to me, which is calcium chloride, which is calcium plus 2, which is 20, plus 2 by 35.5, which is this, and it came up to be 91. And then the molecular weight of silver chloride is 17.8, which is the silver, and chlorine is 35.5. So I got the molecular weights of the two components, and the mass that I know is 200 grams of silver chloride, so I was able to calculate, I can calculate the number of moles of silver chloride that will be produced from this reaction, which is mass divided by the molecular weight, 200 divided by 143.4, this divided by this, to give me the number of moles. Um, so the first step after this to get the solution is to make sure that this equation is balanced, which means that the number of atoms of each species here equals to the number of atoms of the same species on the other side. So calcium is one atom, is coming as one atom, so calcium is okay. The chlorine, I have two atoms of chlorine, but I have only one atom of chlorine here. I have one silver, and I have one silver, so silver is okay. The nitrate is 1, but here the nitrate is 2. So I have the chlorine and nitrate are not balanced. And to balance the equation, we have to just multiply this by 2 and this by 2, and this is gonna balance everything. Calcium is the same, but here nitrate is doubled, and the silver is doubled, and the chlorine is 2 here and it's 2 here. So now the equation is balanced, and I know that from the balance of the equation the ratios is 1 to 2 to 1 to 2. And the information that I know is that the number of moles of silver chloride is 1.4, and from these ratios I can apply what I did before, is do the cross multiplication. So this number of moles that will be used here is this multiplied by this divided by this. It is 1.4 divided by 2, which is 0.7 moles. My goal is to calculate the mass, so I can easily get the mass from the number of moles and molecular weights, which is multiplying the number of moles by the molecular weight. And I've already calculated the molecular weight in the previous slide to be 91, so it's gonna be 63.7. Again, it's important in cases like this to make sure that the equation is balanced and to understand that the ratio is a ratio of moles. I faced cases for students doing this balance by masses. So I said that this is 100 to 100 grams, so this is going to be 100 grams. This is totally wrong. You have to make sure that you are doing the calculations using moles, or the ratios in moles, not in masses. So I hope it's clear now. We might need to solve some more questions in a future tutorial, so I'm gonna do that inshallah later. So I'll see you then.